This problem says, given functions f and g, find on part A, f composed with g of x and its domain, and on part B, g composed with f of x and its domain. And so it gives us the two functions. The first one, f of x, is equal to the square root of x. And the second one, g of x, is equal to x plus 5. So on part A, we're asked to find f composed with g of x. Remember, f composed with g is the same as f of g of x. And so in this case, g of x is x plus 5. So we're going to put x plus 5 in place of g of x, just simple substitution there. So we're going to have f of x plus 5. And so f of x plus 5 just means to evaluate the f function at x plus 5. Meaning everywhere there's an x, we're going to replace it with x plus 5 in the f function. So this is our f function. And so we're going to replace that x with x plus 5. And so we end up with the square root of x plus 5. And so there's f composed with g of x. And now we just need to find its domain. Remember, when finding domain, domain is generally all real numbers, unless you have either a denominator, because remember the denominator can't be 0, or you have a square root, fourth root, sixth root, any even root, because remember what's underneath the even root can't be negative. And so we have a square root here. We can't take the square root of a negative number. So what's underneath it has to be positive or 0. We can take the square root of 0. We can take the square root of a positive. We just can't take the square root of a negative. So the easiest way to find the domain is to take what's underneath that radical. So take the x plus 5 in this case. And we want it to be positive or 0. So we make it greater than or equal to 0. And we see what values make it greater than or equal to 0. So solving that for x, we subtract about 5 from both sides. And we see that x has to be greater than or equal to negative 5. And so then our domain is going to be any values greater than or equal to negative 5. Remember, we put our domain, though, in interval notation, which means anything from negative 5 and greater. And so we start with negative 5 because intervals are always smallest to largest. And so our domain is going to be negative 5. Notice it is included. It does have the or equal to. So we use a bracket, not a parenthesis. And so negative 5 all the way to positive infinity. Any value from negative 5 to infinity, including negative 5, will work in the domain of this function. Now we need to find the other way, g composed with f. So with g composed with f, this time, remember, is the same as g of f of x, which means we're replacing f of x here with the square root of x. We know f of x is the square root of x, so we can use that instead. So we have g of the square root of x, which means we're evaluating the g function at the square root of x, which means in the g function, everywhere there's an x, we're going to replace it with the square root of x. So here's our g function, x plus 5. And so we're going to replace that x with the square root of x. And so we have the square root of x plus 5. And this time we also have to find its domain. Again, the problem here is we've got a square root, and what's underneath the square root can't be negative. So again, take what's underneath the square root, which in this case is just the x, and make it greater than or equal to 0, and that will tell you what values work. Nothing to solve. Any value greater than or equal to 0 will work for x. And so writing that in interval notation, our domain this time, we have anything from 0 to positive infinity, again, including the 0 because it has the or equal to. So we use a bracket, 0 to positive infinity. So now we just need to enter those into our MyMathLab. So for f composed with g of x, that one was the square root. So we need our square root symbol. And then underneath the radical, we have x plus 5. Oh, my plus didn't work. Plus 5. And then the domain there was the bracket. And so bracket -5 to infinity. And then we always use a parenthesis on the infinities. And then for g composed with f of x, we have the square root of x plus 5. So again, square root and then x. And then the plus 5 is not underneath the radical, so we arrow over plus 5. And then the domain for that one, again, we have a bracket, 0, and then positive infinity. And then again, always a parenthesis on the infinities. Oops. And there's our answers.